Hello class, hope everyone's doing well. My name is Chem, and I go to College of the Canyons. It's my second year here at College of the Canyons, and I've been living here pretty much my whole entire life. I'm the oldest of 3 boys, and some of the hobbies I enjoy are cars, MMA, and soccer. I currently have been saving for a new car, and that car is the E92 BMW M3. The reason why I want this car so bad is that this is the last V8 BMW will put into their M3s. My major is mechanical engineering, and I hope on intertwining it with architectural engineering one day. My dream job would be to test drive German cars. The topic I chose for my e-portfolio project is reaction mechanisms. A little bit of background behind a reaction mechanism is that a reaction mechanism is a process in which the chemical reactions occur. Most mechanisms contain at least 2 or more steps in the final chemical reaction. Each step is an elementary reaction, and these elementary reactions, when added, lead to the overall reaction. The coefficients of an elementary reaction are also the exponents of the rate law equation. Intermediates, the species that are produced in one step but consumed in the subsequent step. The difference between a catalyst and an intermediate is that a catalyst is used in the first step and produced in the second step, while an intermediate is the product in the first step and is used in the second step. Molecularity. Each elementary reaction has its own molecule for it and has its own individual steps as part of the whole entire mechanism. Let's look at the total number of particles on the left side of the equation. For a unimolecular reaction, there is only one reactant on the reaction side. For a bimolecular reaction, there are 2 reactants on the reaction side. For a thermomolecular reaction, there are 3 reactants on the reactant side. The rate determining step. The step that is labeled the slow step, and typically the rate law, is determined relative to the overall reaction. There are 2 scenarios. 1, the mechanism with the slow step is the initial step. 2, mechanisms with the fast step as the initial step. The rules in validating a mechanism are 1, the elementary step must add up to the overall reaction. 2, the elementary step must be reasonable and they should generally involve a reactant particle or 2. And 3, the mechanism must correlate with the rate law, not the other way around. Hello class, this is my problem in reference to my topic. What you want to do first is identify the intermediates and double check that the mechanism adds up to the overall. Second, find the rate law for the determining step. Third, solve for the intermediate. Because the first step is fast, we need the forward and reverse rate laws. Because the first step is fast, we need the forward and reverse rate laws. Set your rate forward equal to rate reverse, You do this because of dynamic equilibrium. Then solve for the intermediate. Lastly, you substitute this into the determining step array law.